Hello guys, I hope you're doing well. So here we have an 8-bit shift register, and I just wanted to show you guys how these types of registers work, since they're commonly used in digital electronics. For example, serial communication, we have parallel to serial converters, or serial to parallel converters, and we also find them in ALUs where they are used for multiplication and division. So they're very, very useful. Okay. So what is a shift register? So a shift register is basically an integrated circuit which stores data and also performs uh, left and right shift operations. So what do I mean by that? So whenever you are shifting bits to the left or to the right, essentially what you're doing, right, is you are actually moving bits like to the left or to the right. So whenever you're shifting bits to the left, that's actually multiplication by 2. Whenever you're shifting bits to the right, that's actually division by 2. Okay? So like that's like the whole idea between that. So in order to do that, we have like mode control. So this shift register actually has 4 modes, and these modes are going to be controlled by the mode selectors S0 and S1. Okay, so in this case, if you guys see, I have like you know um, power generators here. So these power generators are going to be sending the appropriate signals, which allow me to switch from one mode to another. So now let me just demonstrate, to see, how exactly this works. So here I have this value here, which is going to be 80 hexadecimal. These displays are going to be showing my values in hexadecimal, by the way. So this value is actually 80 hexadecimal or 128 decimal. Okay. So I'm going to be shifting this value here. I'm going to be storing it in the shift register, and then I'm going to shift this value or these bits to the right 7 times. Okay. So once I'm done, I should have my final output is 1 because 128 is actually to the power 7. So since I'm shifting this value 7 times to the right, I'm essentially dividing it by 2 to the power 7. So if you divide 2 to the power 7 by 2 to the power 7, you simply get 1. Okay, so let me just run it and show you guys what I mean. So essentially right now, as you can see, the data hasn't been loaded yet into the memory. So the shift register is currently waiting for the appropriate signals from the power generators to load in the value. So now the value has been loaded, and now the shifting process has begun. So as you can see, it's being shifted to the right as we speak right now. And the final result is 1, like I was saying. So this is actually 1 hex. This is 80 hex. Okay. So now let's talk a little bit more about these modes. Okay. So for that, I actually have the data sheet for this 8-bit shift register, the 74198. So I'm just going to show you guys the table. Okay, so this is the mode select table here, right? So this is going to be the master reset. There's going to be the clock signal. There's going to be the selectors S0 and S1. Okay, so when the master reset is low, here we have I don't care conditions, meaning that when it's low, simply we're going to have a reset, and these inputs are not going to matter. Okay, so that's basically what it means. So now when it's set to 1, when it's set to high, that's when we can start considering the other the other inputs rather. So let's start with the first mode. So let's start with this one right here. When both S0 and S1 are both high. So when both of them are high, we're going to have a parallel load. So a parallel load basically means we're going to be loading the data into the shift register. So like initially when I was telling you guys that the data has been the bits haven't been loaded into the data yet. Basically, the shift register was waiting for this signal right here for both S0 and S1 to both be high so that it can finally load in the data. Okay, so now let's move on to the second one. So now the second one is when S0 is low and S1 is high. That's when we're going to have a what? A right shift, or shifting to the right, which is actually what I'm doing right now. So let's actually maybe go back. Okay, okay, wait. Let me just finish this, and then I'm going to go back real quick to sort of like demonstrate the modes in action. So, okay, now let's move on to this one. Here, I'm going to have S0 is going to be high, and S1 is going to be low, and we're going to have a left shift, okay? And then lastly, when both of them are low, I'm going to have a hold. So a hold basically means that just store the data, don't perform any operation, just store the data there. Okay, it's almost like the data is only going to be read only. Okay, so these are like the modes. Okay, the four of them. So now let me just go back to Proteus. Okay, so now I'm just going to show you guys these modes in action. So um, let me just stop this. So the reason why I was using these pulse generators and also this clock right here, basically this whole section right here, this is for operation control. What do I mean by that? So since I want to first store the value and then start the process, then after I start the process, I also want to, hold the value maybe for a certain time period, and then I'm going to repeat the process. So for that, I actually need an operational, like operational control where I'm able to switch between different modes. Okay, so I'm going to move from the first mode, which is loading, loading in the data, and then I'm going to move to the second mode where I can either shift my base to the left or to the right, for a given time period, okay, or for a given number of times. So that's why I needed this circuit right here. So basically here, if I look into this clock has a frequency of 0.05 hertz, sorry, hertz, which is basically a period of 20 seconds, right? So basically, what this means is these two pulse generators are going to be sending pulses after every 20 seconds. Okay, that's basically what the clock is for. It's going to dictate the delay between the pulses being sent by these these two pulse generators. Okay, now let's move on to the S0 pulse generator. So as you can see, it has a pulse width of 0.5 seconds, which basically means it's only going to last for 0.5 seconds. That's simply what it means. And let's move on to the pulse width for S1, which is 8 seconds, which means it's going to last for 8 seconds, or it has a period of 8 seconds. So now, let me show you guys, the operational control in action. So for that, I'm going to be using the oscilloscope to show you, to show you that. So let me first run it, and I'm gonna go to show the oscilloscope. So as you can see currently, okay, maybe I also need to explain the signals for the oscilloscope before I forget. So channel A is, as you can see, is going to be showing us the signal for the S0 power generator, and channel B is going to be showing us the signal for S1. Okay, so S0 is basically going to be yellow. This is S0. This is going to be S1. So currently both of them are low. So that's why you guys, that's why you see that in the output, we simply still have the default value, which is 0, 0, 0 hex, because the data hasn't been loaded yet. So right now, the shift register is still waiting for the appropriate signal, which is going to be for both S0 and S1 to be high. Okay. So now let me just continue. Let me, okay, so let's see what happens. Okay, still we're waiting for those, for the signal. And as you can see, did you see that? So when both S0 and S1 are high, this is when the data was finally loaded into the shift register. Okay. So now, after that, like what happens? So now after the data has been loaded, we can either choose to, shift to the right or shift to the left, right? So in this case, since I'm shifting to the right, if I go back to the table, to shift to the right, S0 has to be low and S1 has to be high, right? So after this section right here, like after the the loading of the data, like after the parallel load, as you can see, S1 now becomes zero. You see that, right? S1 now becomes zero, and S0 now becomes zero, and S1 is still going to be high. So now that means here we have a mode switch, like like we basically were able to switch from one mode to another. So now this was the first mode, the parallel load mode, and now in this section right here and going forth, we're now in the second mode, which is the shift right mode. So let me just show you guys what I mean. So now you see the shifting process has begun. You see right here, the shifting process has been started. You see that, right? Exactly. So essentially, that was like the whole process. So you see right here, this was still low. You see, this was still high, right? And then finally, S1 was also switched to to one. So now that means both of them are now zero, right? So if both of them are zero, which mode is that? Let's go back. It's this mode right here, the hold mode. So now that means we're able to move from the parallel load mode to the shift right mode, and then finally to the hold mode. So that's why you see this value right here. It's not changing. You see, the value is not changing. It's still going to be the same for quite some time until the next cycle. Okay, so that's like the whole idea. So actually, sort of like drew like a small graph to show you guys how it basically works in action. Actually, this is supposed to be S1 and this is supposed to be S0. Okay, so initially both of them were low, right? Both of them were low, and then now they shot up to high. Do you see that? So in the A section, this is basically the parallel load mode. When both of them are high, that means we're going to load in the data. After that, now we move on to the second mode, which is the shift right mode, when S1 is going to be 1 and S0 is going to be 0, which is basically right here. Okay. And then after that, now we move on to the last mode, which is going to be the hold mode, when both of them are low again, where where we're just going to hold the value and just store it. So that's actually how I was able to implement like operational control without having to use you know like buttons, push buttons and stuff like that. So anyways, now let's try to um you know let's try maybe to do like a left shift. Okay, let's try to do a left shift real quick. So let me just stop this. Okay, let me just so in order for me to do a left shift, what I simply need to do, the only thing that I really need to do is to change the periods for the pulses. Okay, so here I'm gonna have 8 seconds, and then here I'm gonna have 0.5 seconds, 0.5 seconds. Okay, and now what I can simply do now is, since I'm going to be shifting to the left now, I'm gonna start here, then my bit is going to move all the way until, so basically it's going to start here. I'm gonna move all the way until it gets to the MSB. Okay, so let's run it. We're still waiting for the parallel load pulses or signal, and then we can load in our data. And now you see, now this is a left shift, and now we're basically multiplying our number by 2, and you see the final value is going to be 80. That means it's going to be 2 to the power 8. So basically I multiplied 1 by, sorry, 2 to the power 7 rather. So I basically multiplied 1 by 2 to the power 7, or 128. So yeah, that's the whole idea, essentially. That's like the whole idea of this. So I hope you guys learned something. And yeah, you know, that's basically it. And see you guys in the next one.